Hello and welcome. We're going to talk about factoring quadratic expressions. Our goal here is to get at the nuts and bolts of factoring quadratics as we explore the relationship between the coefficients in the quadratic and its factors. So remember our quadratic expression, our general form, looks like this: ax squared plus bx plus c. It's a degree 2 polynomial, and the x could be a different variable. It could be y or z or t or whatever. I'm going to stick with x here. And also, first, to make this a little bit easier to start with, I'm going to start with a being equal to 1. Later, we'll talk about what happens when that leading coefficient is not 1. So for now, we'll have x squared plus bx plus c. So a, b, and c are all real numbers. And here, as we're talking about factoring, they're actually going to be integers even. In general, they can be any real number, but for purposes of factoring, we're going to stick to integers. So, one thing to note is that if this x squared plus bx plus c factors, if it factors, it's going to factor into two binomials. It's going to be product of two binomials. I'm just going to write it x plus u times x plus v, say. So our goal is to go from here to here. We want to find these two numbers, u and v. Let's multiply that out. FOIL it out. X squared plus ux plus vx plus uv. I'm going to simplify this a little bit. I'm going to combine these like terms here. Combining them basically means factoring the x out of those two terms. So x squared plus u plus v times x plus uv. Now remember, this is x squared plus bx plus c. That means our c, our constant term in our quadratic expression, has got to be equal to the product of the two numbers we're trying to find. And the b, the coefficient on the x term, is equal to the sum of those two numbers we're trying to find, u and v. So c equals u times v, b equals u plus v. So to factor, find two numbers that multiply or whose product to uv and add to u plus v. Now u plus v the u and v may be opposite signs or the same sign, and that will affect what the sign is of b, and it will also affect whether that addition, u plus v, is technically a subtraction or not. We'll see that in a second. Okay, so let's look at an example. Just to keep it simple. So let's look at x squared plus 3x plus 2. X squared plus 3x plus 2. Let's factor that. Well, let's find two numbers whose product, they multiply to 2, and they add to 3. Well, guess what? There's only one possibility here, 1 and 2. They add to 3. When you start, you can kind of write these two binomials from the start, and you know that these two have to be x, because it's got to be x times x is x squared plus 1 plus 2. And those 1 and 2 multiply to positive 2. So they're the same sign. In fact, the same sign, they're both positive. They need to be positive because of this term, as we'll see in a bit. Let's look at this one, x squared minus 5x plus 6. Let's factor this. Well, we need the product. We need two numbers that multiply to 6, whose sum is 5. Well, you could run through all the divisor pairs of 6, which there aren't many. 1 and 6, 2 and 3. That's it. Well, let's look at the sum. 6 plus 1 is 7. That's not right. So 2 plus 3, that's 5. So there it is. Now what this means, here's our x's, is that we have a 2 and a 3 here. They add to 5. So those are correct. They need to be the same sign because this product is positive. Whatever 2 and 3 are, they have to both be positive or both be negative. This middle term here tells us oh, they add to a negative 5x, so they must have to both be negative. So the signs on B and C give us some information about whether we're looking for a sum or a difference, and about what the signs of those numbers in the factors are. Let's just explore this a little bit. Let's just look at these possibilities. X plus 2 times x plus 3. We already see x minus 2 times x minus 3, but let's multiply these out first. So x plus 2 times x plus 3, they're the same sign. So when we FOIL this out, when we multiply this out, you get x squared. You get a 3x and a 2x. That'll give you 5x. Plus 2 times 3, 6. If they're negative, we already see what happens there. You get x squared, negative 3x and negative 2x, right? Negative 3x and negative 2x gives you a negative 5x. They collect to negative 5x. But it's still plus 6 here because they're both the same sign. So the sign on this number means that the two numbers we're looking for, u and v, in this case 2 and 3, the two numbers we're looking for are the same sign. They're either both positive or both negative. If the same sign, then we're looking for a sum. Same sign, sum. This sign on the B term tells us what sign those are. This says that they're both negative. So let's look at what happens when we have opposite signs or different signs. Multiply this out, we get x squared minus 2x plus 3x. So that's 3x minus 2x, right? I'll write it out actually just to make it clear. 3x minus 2x minus 6, the negative 2 times 3. So that means we get x squared plus 1x minus 6. Now the sign on our C, on our constant term, is negative. So this means that they're different signs. The two numbers we're looking for have different signs, which means it's a difference. We're looking at a difference between those two numbers. This part here is a difference. So whereas before the middle number, the middle term, is a sum of the two numbers, 2 and 3, here our middle term is the difference of the two numbers we're looking for, 2 and 3. In this case, this is negative 2 and positive 3, which gives us a positive sign on the middle term. And that basically says we're taking a difference of a positive number and a negative number. Well, the bigger number is going to win the tug of war here. The larger number is positive. Let's look at what happens if they switch signs. Here we get x squared minus x minus 6, because we get a negative 3x and a positive 2x. That's negative x when you add those together. Same deal. The C term is negative, so that means we're looking at a different sign than on the two numbers. And the larger number is, in this case, now, larger number is negative. So if I was going to give you a basic idea here, to factor x squared plus bx plus c, find two numbers that multiply to c, whose product is c. If c is positive, greater than 0, then they're the same sign, which means that you're looking for a sum to b. If c is negative, then the two numbers you're looking for are different signs, which means that their difference is b. I'm showing you this way because otherwise you'd have to check all the possible sign combinations of your numbers, and really you don't have to worry about the signs. All that's important is whether they're the same sign or the different sign, and you can determine what those signs are later after you figured out the two numbers. B will tell you what the sign is. So in the case that c is positive, then both are the sign of b, the same sign as b. And in the case that c is negative, then the larger number's sign is the same as b. That's a little algorithm if you like. But it really just comes from getting a feel for how those two numbers in the binomials interact, and basically how the binomials themselves interact when they are multiplied. So let's see this in action. X squared minus 10x plus 24. So say we want to factor this, x squared minus 10x plus 24. So I'm going to look for two numbers whose product is 24. And because 24 is positive, I'm looking for, they're the same sign, because they have to be the same sign to multiply 24, which means I'm looking for a sum. The middle term will be a sum. The same sign, sum. Well, if you don't, you may already be able to see what multiplies to 24 and adds to 10. I'm not worried about negative. We'll figure out the negative. This negative here tells us that it will be both the numbers will be negative, but we'll get to that in a second. But we're just looking for two numbers that multiply to 24 and add up to 10. Well, you may already see it, but if you don't, you can write out your divisor pairs. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Oh, there it is, right? But if you have to, write out the sums. 25, 14, 11, there's 10. That's it. So what that means is you got 4 and 6. They're the same sign. This term tells you they're both negative. Negative 4x plus negative 6x. And that's it. After you've done this a while, you won't have to always write a list of all the divisors. I'm just showing you a systematic way, a systematic thing you can do in case you can't just immediately see it. Here's another one. X squared minus 10x minus 24. Well, looks very similar. Oh, except the signs are different, right? So I've changed just the sign of one of the numbers, 24. But that changes the problem. And by coincidence, everything else looks the same. So let's look. We've got our product is still 24. Got to find two numbers that multiply 24. But now this says they're opposite signs. They're different signs, which means we're looking for a difference. And we want it to be equal to 10 still. Not going to worry about the negative on it. If you like to remind yourself that this is a difference, we can write negative 24 here to remind yourself it's a difference. That's fine. Let's look. You can go through the whole process again. 124, 212, 38, 46. The difference in each of these cases is 23. I'm just taking larger minus smaller. 12 minus 2 is 10. 8 minus 3 is 5. And 6 minus 4 is 2. We could have stopped right here because we found 10. So that means we've got x here, x here. We've got a 2 and a 12. Now, which one's positive, which one's negative? The larger number matches the sign of b, in this case negative 10. So the larger number has to be 12 and the smaller number has to be 2. If this was a plus on the 10x, then these two would be switched. The 12 would be positive and the 2 would be negative. But it would still be different signs, still be a difference. So see how I don't have to fiddle around with figuring out all the different sign combinations to get the right thing. I just know it's got to be a difference, and then I look at B and it tells me what the signs are. See if we can do this a little quicker. After a while, you can just start writing this first, and then think, okay, what two numbers multiply to 3? It's positive, so they have to sum to 4. Well, there's only one choice, 1 and 3, right? So if these don't sum to 4, if they don't add to 4, then this doesn't factor. Turns out they're both negative because it's negative 4, right? If it was something like x squared minus 7x plus 3, then it just doesn't factor. Because there aren't two integers, I should say, that multiply to 3 and add to 7. There might be other ways to factor this using non-integers, but we're not there. Speaking of 7x, let's look at x squared minus 7x plus 12. Again, same sign, and they're going to both be negative. So I'm looking for two numbers that multiply to 12 whose sum is 7. Well, you probably already know. If you don't, you can go through them still. Let's see if we can just do it. You might notice that these are still x. You got 3 and 4. 3 and 4 multiply to 12 and add to 7. We're good to go. If you didn't, you could write all the divisor pairs of 12 here. 13, 8, and 7. And these are both negative. And by the way, these three possibilities are the only possible integer coefficient quadratics with a last coefficient of 12. With some possible changes in your b term. You could have plus or minus on those on the b term. Anyway, that's it. How about x squared plus 3x minus 18? X. Now we want to find two numbers that multiply to 18, or negative 18 if you like. And it's negative, so that means we're looking for a difference. Our difference we're looking for is positive 3, or just 3. We'll worry about the signs of our two numbers later. But again, 1 and 18, you can write them out. If you already know what two numbers multiply to 18 and whose difference is 3, then you're good to go. 1 and 18 has a difference of 17. 2 and 9 has a difference of 7. And this here it is, 3 and 6. That'll have a difference of 3. We got it. So we just have a 3 and a 6 here. And this number here tells us which sign the bigger number is. The 6 is bigger. So it gets the plus. And it's not a bad idea to re-multiply these out to check. X squared, negative 3x plus 6x. That's going to be 3x. Yes, positive 3x. And then negative 3 times 6 is negative 18. So we're good to go. Not a bad idea to check those. Four x squared plus 8x plus 4. I promise not to deal with any problems where a was not 1, but sometimes if you can see a common factor in all the terms, you're going to want to factor that out first anyway. It'll make all your numbers inside better. So the first step, before you even do this factoring into two binomials, check to see if there's a common factor in all the terms that you can factor out to make your life easier. The common factor here is 4, and I keep it on the outside. I keep it there. It's still part of the factorization, but it does make the inside easier. X squared plus 2x plus 1. Now I just need to find two numbers that multiply to 1, positive 1, so they're same sign, and sum to 2. Oh, 1 and 1 multiply to 1, and they add to 2. So and they're both positive, so there we go. You could write it like that, or you could write it like this, x plus 1 squared. That squares squaring the x plus 1, which is written like this. It does not square the 4 because of order of operations. That's all I have for now. See you next time.